Okay, please ask your friends to join. They can refresh their browser, Blackboard browser, and log into the Blackboard details. If somebody is not able to log in, then you can ask them to refresh their browsers. It would be easier for them to access this session. So I'm just putting a question for you. Okay, can you answer this query? Yes, please. Yes, please answer. Many students, 9 students have not replied. Rest of the students have replied. Yes, please. 2 students have not replied yet. Yes, please reply. Kunal Verma has not replied. Kunal Verma has not replied. So yes, I'm going to share the responses with you. Many students have also replied wrongly. Okay, so it was last time we were having the topic of SIMS, which is secondary ion mass spectroscopy. Okay, so let's discuss it again, what we are talking about and how it would be possible for us to know about the SIMS data. So let's have a quick look and about the last time what we have done. I would like to share the screen. So sharing screen. Okay, so if you have a look at the last time, then we were having this one. Okay? So what we have done that we tried to understand that what is the SIMS measurements and how does it work. And these ions, they will be incident onto the surface of the sample. We have to make it clear that there are primary ion sources, okay, and these ion sources can be any of the ions depending on the requirement. And what is your requirement? That will be indirectly related to the type of the sample. But for example, if you are using cesium ion, if you can also use the oxygen positive, oxygen ions in this case. So what will happen that ions in the primary ion source, they will be incident onto the surface of the sample, and from there they will eject the secondary electrons. And there will be a mass analyzer, and what will happen that you would have different trajectories of the ions, the secondary ions in this case, then they will go to the detector in this case. So what you can do that you can the range of different ions, okay, depending on their charge to mass ratio. So that we have to see in detail. So that we have to make it clear. No? That after this, what we have done that we have also discussed that what is a electron multiplier, how does it work, and how many electrons. Sometimes what happens that if you have one electron, then the corresponding to one electron, how many electrons will be generated the electron multiplier. Okay, so that we have also discussed in this case. No? Now we also discussed that what are the diodes and what is the what would be the possible value of the work function for the diodes. What is work function? Work function is the energy which is required to knock out one electron from the surface of the metal. So what will happen in this case that you need to have diode material should be having low work function, so that you need to have minimum energy in order to get the ions from the or the electrons from the diodes. So make it sure the ions will be incident, electrons will be liberated from the diodes in this case. That is the procedure which we have discussed, and overall idea was to discuss this SIMS measurement, that how does it work. So what we are going to do today, that we would like to have a closer look at the data, and I hope that this lecture would be beneficial for the students, those who are working with the SIMS measurements, and not only for them but all of the students, those who would like to opt it as their career in future perspective. No? So make it that we understand the things in detail. No? So right now, if you have, let's uh, pull out the information for you. So what we would have that the information. First of all, I would like to share the whiteboard and try to understand that what is this the mass analyzer, no? And how does it work? No? That would be our target in this case. So still we are talking about the SIMS measurements. So it is secondary and mass. That's good. Somebody is writing, and even I know that who is writing. But I would not tell your name. That's good. Very good. Hello. Hi. Can you still try to write it again? Okay. Hello. Hi. Can you write it further? Okay. So that's a good habit. No? Anyway. So what we are going to do? Okay. So we are going to talk about this secondary and mass spectrometry. Okay, we are going to talk about this. Spectrometry, and here I can make it slightly bigger. So we are having this and we can also add the SIMS. Okay. Now, if you have uh, understood this SIMS measurement, then we have to make it sure that how does it work. No? So let's have a look at it, and let me enclose that in the possible. So what we are trying to do that here, how does a mass analyzer works? No? How does a mass analyzer that works? No? So mass analyzer is basically, for example, what you are trying to do. You are having what is the magnetic, if you place a charged particle in the magnetic field, how much force it will have. No? So what we are trying to do, we are writing it with the help of F is equal to Q E cross B. So that is the thing which we have learned in the elementary classes. Okay, and here the if you take the magnitude, so what you would have if you want to solve that, Q VB sine of theta. Okay, so if you would like to calculate this, if theta f is equal to this value, if theta is equal to 90 degree, so in that case what will happen, if the angle between the V and B is 90 degree, in that case f will be equal to QVB. No? QVB. Okay, so that is the first thing which we need to understand from here. No? Now we have to make it clear that what are the details in this case. So let's have this magnetic force which is there. Okay, so if you put this QVB is equal to, what I'm doing, that if you have this mv square over r. So what I have done, that if you have in the magnetic field, what would be the trajectory of the charged particle? If you would like to understand that, that can be understood in this term. Okay. Okay. So what you would have, if you calculate Q by M from this expression, then it will come out to be what? Here you would have M, you already, it is gone, and then V over RB. No? Okay. And this is equation number 1, if I would like to say this one. And now what if you want to have the electric and magnetic forces? Let's say that the electric force on the charge carrier and the magnetic force on the charge carrier, they are equal. In that case, what will happen? Okay, so what is the electric force? It is the QE, no? QE. And what is the magnetic force? Magnetic force is the QVB, okay? So what it would be that Q and Q will cancel, and you can calculate the value of V from here. V will be equal to E over B, no? E over B, okay? And we are saying that this is equation number 2 in this case. So here, what we will have, we would like to come to one point and try to understand that what is the actual meaning of this system, which we would like to understand. If you would like to put this value of V in equation 1, then what would be the final expression? Your final expression will be Q by M is equal to, you would have here, instead of V, what you will put? You will put E over B. And what is remaining? You would have RB. No? So the answer would be that it implies that Q by M is equal to E over RB square. Okay? This is the expression about which we are talking about. In this case, sorry, let's have limited features in the Blackboard. Okay, we have this Q by M, and now what is what are the different terms? What is R? R is the trajectory when your charged particle is placed in the electromagnetic field. What you are trying to do, let's say that let's do that in a simple way. What you would have here, say that here what you are trying to do, you would have this the source which is emitting the ion, okay, which is giving you the charge, okay. And then what you have done, that you have applied the electric field in this region, okay. What you have done, the electric field is applied in this region, okay. So what is this? This is the value of E, no? E. And then the ion which is coming from here, no? The ion which is coming from here, that we have to see, no? How does it go around this region? So let's have a bit closer look at this, although this is having width, okay. Or we can just draw it, no problem, with the hand so that we can understand. Like this trajectory. And what we have done, that we have also applied the magnetic field, no? The electric field is only applied in this region, and magnetic field, that is perpendicular in this case, but it is applied in the entire region, okay. So E is only in this region where you are reflecting the electrons or the charge carriers. This is the source, okay. So what will happen in this case, that your the trajectory, okay, for example, if you would like to come across this one, what would be the trajectory in this case? What would be the radius of curvature of this one, okay? So this will be the value of R in this case. Then what you are trying to do, that here, if you look into the details, you would have let's say that I am plotting it here. I have two blocks over here, okay. So somewhere here I would have the detector. Okay, the situation should be a bit clearer in our mind. So what will happen that here your Q by M is equal to E by R square. Okay, so it implies that if you want to calculate it, so what you can do that here you would have this value of R will be equal to E, and if you it is Q by M, and here you would have B square. No? So what will happen that if you have a higher value of Q by M, in that case, what will happen? The radius of curvature of the trajectory of that ion, that will be smaller. Okay, let me make it clear. So if you would have Q is larger, okay, Q by M is large. In that case, what will happen? R will be small. Okay, and if your Q by M is small, in that case what will happen? R will be large. Okay? R will be large. Okay? Let's try to understand this with this figure which we have given here. Okay, again what you would have, these are the two blocks, okay, which can block the these are the two blocks, okay, which we are talking about. Okay, this is one block, this is second block, and what we are trying to do, we are trying to make the trajectory of electrons or the charge carriers from here to here. Okay, so what will happen that here when they are deflected, in this case, will they go to detector? This is the detector. Okay? This is the detector. Will they go to the detector D or not? That will depend on the charge to mass ratio. If you would have larger value of Q by M, R will be small. So what will happen? That if R is small, in that case, what will happen? I'm just drawing it. Okay, let me do that with the help of some red color. Okay. So what I'm doing, that you would have the solar trajectory, and it will go like this one. If you now let's begin. Okay, so what we are trying to, let's do it green. Okay, next one. Okay, if you would have the M value smaller, then R will be larger. What will happen in that case? Let me, okay, I am drawing that with the help of the green one, and then it will. So what will happen? The red one, which is having the R small value of R, and the green one, which is having the larger value of R, they will not be going to the detector. Okay? They will be blocked with these blocks. Okay, these are the blocks. Okay? What we are trying to do, that this is the block. Okay, so instead of plotting this with green, because this is not visible, I am making it black. Okay, this is black. Okay? So here your R for the red one, what you are talking about, if you would like to talk about it, you are talking about R is small in the case of. So what you are trying to do, you are talking about, what you are talking about, which case you are talking about, this case. Okay, the first case, in this case, when you are talking about R is large, in that case what you are talking about, so you are talking about this case, in this case. Okay, is it clear for us, or I don't know if you guys are with me, or let me have. Sir, can you please explain that in a clear board? Who is talking? Divya? Clear board means that it's not visible to you. Divya, you can talk to me. Divya? Clear board means that is it not visible to you?
Sir, it's visible. Anvesha is asking for clear board. Maybe he wants on another
Clear
board.
board.
Just diagram.
Clear board means that new the So let's make it clear. Do you know that how to zoom in and zoom out your blackboard?
Yes, sir.
Okay, so if you are not able to see something, then you can go to the top left corner, show view control, no? Okay, and then you would have what you can do, that you can zoom out. I am zooming out right now, no? Is it zoomed out or not in your case? Is it same size or no? No. Okay, no. So but you can zoom in your if you go to, okay, so if you go to this the left portion, then you can see it. Okay, so that's again, maybe I will lose it. That's the problem with the blackboard. Okay, so let me save it as a print screen first of all. No, sorry, I cannot do that in the Windows. Okay, so let me, anyway, to keep this, can somebody take print the screenshot of this whiteboard? Take the screenshot in your record, screenshot of this whiteboard. Okay, okay, and please take, anybody can take the screenshot of this whiteboard, and then I would like to show you that how to do that, no? So let me go to this share screen. Okay, I'm sharing screen right now. Okay, so right now what I would like to show you guys, that if you have, so you if you have this, you can go to this top left view controls. Okay, and if you have any text which is written smaller, you can zoom it out. Okay, zoom it out. If you have whiteboard in front of you, you can zoom it out, make it bigger, and then you can scroll. Okay, for example, when you made it bigger, then you can scroll it down from here. Okay, okay, so you will not face any. I mean that the this is everything. Most of the things are available here in the Blackboard. No? You, sometimes we are not knowing about the features, so we can see that. Okay, okay. So make it sure that if you have some viewing problem, if the text is so small or any problem, in that case you can have this the, okay, no problem. Okay, let's
सर
take it. Yes, Divya.
अन्वेषा का मतलब था कि सिर्फ डायग्राम और बोर्ड पे समझ, वो बोल रहे कि बहुत सारा लिखा हुआ है बोर्ड पे, अभी में डायग्राम
Diagram we
समझाना
have,
है।
oh yeah, we can make that, no problem. Okay, diagram we can make it on separate, no problem. It's not only, I mean that only few students should understand, every student should understand that. Okay, so that is our aim. Anyway, I'm just switching off this screen, and we would like to make it bigger. That's a big problem with this, no? Today I am using my Windows instead of my Mac, so I cannot use the good one, the whiteboard which is there, no? So that's the reason. But that is due to the reason because I was trying to show you some data. I was planning to show you some data which is only compatible with Windows, the software Origin Lab. You might be knowing that. No? Okay, so what we would have here, let's get into the right mode. So what we are trying to do, that here your charge particle is coming in this direction. Okay, and from here what you would have, that you have applied the field in this direction, electric field is in this direction. Okay, this is the electric field. Okay, this region, and then you would have also the magnetic field. Okay, so you would have the magnetic field which is in all the region. Okay, You can apply, what you can do, you can apply the Lorentz law always to get the right direction. Okay? What I would like to say here, that I am telling you what is the basic principle of the mass analyzer. That I would like to highlight here. Okay? So if you look at that, this okay, so what we are trying to do with the help of this, that we would like to make the blocks here. Let's say this block, and here you have the detector. Okay, detector D. This is block. Okay, block means that it will not allow your charge particle to go ahead. Okay, okay, this will go, but this will not go. This will not go. This will not go. No? So what we have done, that your trajectories. So what I have seen, that what will happen here, the R value, the radius of curvature in this case, that is inversely proportional to the what it is. It is inversely proportional to Q by M. Okay. Okay. Is it clear? So you would have this Q by M, which you are talking about. This portion. Can you just see it now, that if you would have Q by M small, okay, so what will happen if it is Q by M is small, your R will be large, okay? Radius of curvature will be large. Is it? So you are talking about this, the radius of curvature, okay, this is the radius of curvature, this is R value, you know, in this case. The R value in this case will be, for this curve, will be like this, no? Let's say that this is the R value. In this case, okay, you would have the smaller value, okay, of the R, okay, that will keep on decreasing in this case. No? Let's say that, okay, like this, no? Okay, make it sure that, okay, you are talking about, you would have a center, you would have, this is larger value of R, this is smaller value of R. So what will happen, only these ions which are there in this case, they will cross and go to the detector. Okay. The rest of them, they will be blocked. This will be blocked. This will be blocked. All the ions which are having the Q by M ratio in this range, they will be allowed to go through, and this others, they will be blocked. This is called, this is the basic principle of the mass analyzer. Okay. Talk to me, Divya, or any other student, Navesha, any other student, talk to me. Mass analyzer. Okay. Jyot, are you there? I have enabled your voice or not? You guys are there? Yeah, I have enabled your voice. Yes, you can talk. Prabjot, are you there? Let's see, Prabjot or Pavanjot. Pavanjot, are you there? Pavanjot is not there. He is oftenly absent from important lectures. No? Okay, any question? Is it clear or not? Is it clear? Okay. Yeah, so only there is nothing, that is a point, only we are saying that radius of curvature of the trajectories of the charge carriers in the electromagnetic field, that depends on the Q by M ratio. The higher the value of the Q by M ratio, smaller will be the value of the radius of the trajectory, and that will not hit in this case. So what you would have, so your this one, that will not hit. Okay, this will not go to the detector, this will not go to the detector, this will go to the detector, because the range of the Q by M is in this. Okay, so this value is called the selection of the charge carriers on the basis of Q by M ratio, or it is also known as the mass analyzer. What we have done, if you recall that in your previous lecture, we have done this thing. So I am sharing screen with you guys. So we are sharing screen. If you look at here, okay, if you have here, okay, so this was the mass analyzer. What we were trying to do, that in case of the mass analyzer, you are trying to understand that all the secondary ions which are during this process, they will not go to the detector. Only selected of the ions, they will go to the detector, and it will be decided on the basis of the Q by M ratio, which will decide the trajectory, this trajectory, whether it will go or not. Okay, so what will happen from here, inside this one, this mass analyzer will work on the principle of the Q by M ratio in this case. No? That is the overall aim of ours in this case. Now let me open a few files for you guys. Okay, so maybe I can open these files for which I have been here. Let me open this origin lab. And I hope that I'm sharing the screen with you guys. Yes, I'm sharing the screen. So what will happen, that in case of the origin lab program, if you are familiar with this one, so let me have some data for you. Let's say that if you have any file which I would like to put it here. So let's see that this one. Okay, I'm putting forward this one of the file to show you the data. So I'm putting this this file here. So from here, what we can do, that we would have this. Okay, I can show you the data, the different one. So I'm just showing you the raw data in this case. So we have this raw data in this case. That let me show you this one. For example, if I would like to plot this, okay, so you would have this type of the data, no? Along x-axis, you would have the okay. Along y-axis, you would have the intensity or number of counts. Okay. And along x-axis, you have this the value of x, okay, depth. So what we can do, this is the SIMS data. For what we have different type of the layers, and we would like to know that what is the aluminum content in this case. For example, if we have any material, like you are talking about the this is aluminum gallium arsenide, no? And oblique you would have gallium arsenide also, gallium arsenide. What you would have in this case, that from here, if I would like to make this bit bigger or thicker, this line like 4, okay. So what you can see from this data, that you can have, you want to know that how much is the concentration of the aluminum in the material. And how to do that, what you will do, that from here you go to the analysis, and from here mathematics, okay, and integrate, okay. If you would like to integrate, then you have to define the range. Let me define the ranges in this case. Let's say that from here to this value. So what you can do, that in this case you would have this the analysis, then you would like to integrate. So if you would like to, so if you integrate this one, then you would have this curve, which I would like to show you guys, but somehow it is not working. You have different okay, it will give you the value of the integration, that what is the area under this curve, no? That can be understood with the help of this one, okay. And if you want to calculate that, okay, so I can show you one of the graphs that will give you this value, no? For example, this one, or okay, like this one, okay. For example, from here you can calculate the area, and this integration will give you this. If you divide these two numbers, that will give you the value of this area under curve, no? From here you can estimate the aluminum content. Okay, we would like to continue in our next lecture for more information. If do not hesitate to talk if you have any question. Yes, please. If you have any question, please don't hesitate to talk to me. Yes. If you have any question, please don't hesitate to talk to me. Yes, please. Yes, please. Okay, if you want to leave the session, you can.